Hi, in this video we will cover the fourth subtopic of chapter 1, composition of functions. At the end of this section, we can combine functions, we can create a new function by composition, we can evaluate composite functions and find the domain of the composite functions, decompose composite functions. So suppose we want to find the total income of a family in a year. So the total income is income of husband plus income of wife in that year. For each year, we can say that the total income is income of husband plus income of wife. We can focus only on income and we can add them. So when inputs and outputs are same kind, we can add, multiply, divide functions, and this is combination. This is combining functions. So here we have operations of combining functions. F plus g of x is equal to f of x plus g of x. F minus g of x is equal to f of x minus g of x. F g x is equal to f of x times g of x, and f divided by g of x is equal to f of x over g of x. Find and simplify functions g minus f of x, g over f of x, f given f of x and g of x. Are they same functions? So let's find this one first. G minus f of x is equal to g of x minus f of x. So g of x is x squared minus 1 minus x minus 1, and that's equal to x squared minus 1 minus x plus 1. So it's equal to x squared minus x is equal to x minus 1. And this one, g over f of x is equal to g of x over f of x is equal to g of x squared minus 1 over x minus 1 is equal to x minus 1 factoring x plus 1 divided by x minus 1. If where x is not equal to 1, x cannot be equal to 1, because if x is equal to 1 then it's undefined. So before simplifying we need to tell that x cannot be 1, otherwise we're not allowed to simplify. So the answer is x plus 1. So x plus 1 and x times x minus 1, they are different, not same. Here is the solution. Find and simplify the functions f g of x and f minus g of x, given f of x and g of x. So f g x is equal to f of x times g of x. It's equal to f of x is x minus 1, g of x is x squared minus 1. So the answer is x to the third minus x squared plus 1. It's equal to x to the third minus x squared minus x plus 1. And f minus gx, f minus g of x is equal to f of x minus g of x, and that's equal to x minus 1 minus x squared minus 1 is equal to x minus 1 minus x squared plus 1, which is equal to x minus x squared. So again, they are not same functions. In this section, we want to learn about composition of functions. We learned about f of x. Sometimes we need to composite the functions. So instead of having x as input, we have another function, g of x, as input. Sometimes output of one function is input of another function. For example, cost of living in a city is a function of the electricity, and electricity is a function of temperature. When temperature goes up, more air can be used. So output of one function is input of another function. So we need to use composition of functions. We read this from left side, f composed with g, f composed with g, and right side we read f of g of x. So it's important to know that f of g of x is not a multiplication, is not equal to f of x times g of x. Using the functions provided, find f of g of x and g of f of x. Determine if the composition is commutative. First of all, what does it mean, commutative? So commutative property in math is a property that changes in orders does not change the result. For example, a plus b is equal to b plus a. It's a commutative property. ab is equal to ba. 3 times 4 is equal to 4 times 3. So now let's go back to the question. F of g of x, f of x is equal to 2x plus 1. F of g of x must be equal to 2 times g of x plus 1. G of x is 3 minus x, so 3 minus x plus 1 is equal to 6 minus 2x plus 1, and that's equal to minus 2x plus 7. And g of now g of f of x. So g of x is equal to 3 minus x. G of f of x must be equal to 3 minus f of x, and that's equal to 3 minus 2x plus 1 equal to 3 minus 2x minus 1, and that's equal to minus 2x minus 2. So is it commutative? No, it's not, because f of g of x is not equal to g of f of x, so it's not commutative. The function c of s gives us the number of calories burned completing s setups. So c of s, calorie c, is a function of number of setups, and s of t, gives the number of setups can complete in t-minutes. So ts is the setups, number of setups is a function of time. Interpret c of s of 3. C of s of 3. So 3 is time, 3 minutes. S of 3, number of setups that will happen in 3 minutes. It will give us one output, and that output is used as input for calorie. So C of S of 3 is the amount of calorie that one person burn in 3 minutes. Here is the solution, and here is another example. So suppose f of x gives miles that can be driven in x hours. So f of x miles in x hours. G of y gallons of gas in y miles. So which one makes sense? F of g of y or g of f of x? F of g of y means mile in x hour is a function of gallons. How many miles is going? Is it dependent on gallons? And g of f of x means that the gallons of gas that is used is a function of miles, how much the car is going. So this one makes sense. The amount of gas, gallon of gas, is a function of miles that is being traveled by the car. Let's see. Using table, evaluate f of g of 3 and g of f of 3. So let's start with f of g of 3. We need to find g of 3 first. So what is g of 3? So x is equal to 3. When x is 3, g of x is 2. So g of 3 is equal to 2. Now we substitute f of 2. What is f of 2? So x is 2. What is f of x? 8. 8. So f of g of 3 is equal to 8. Now next one, g of f of 3. G of f of 3. Again, we need to find f of 3 first. So x is 3. F of 3 is also 3. F of 3 is equal to 3. Now g of 3, what is it? Is 2. So g of f of 3 is equal to 2. Here is the solution, and in next section we learn how to evaluate composite function using graphs. So evaluate f of g of 1. F of g of 1. First we need to find g of 1. G of 1. When x is equal to 1, what is g of x? So x is 1. G of 1 is 3. Now we need to find f of 3. f of 3. What is it? So x is equal to 3, f is equal to 6. So f of 3 is 6. We can say that f of g of 1 is equal to 6. Given f of t is equal to t squared minus t and h of x is equal to 3x plus 2, evaluate f of h of 1. So h of 1 first, we need to find h of 1. h of 1 is equal to 3 times 1 plus 2, which is equal to 5. Now we need to find f of 5. So f of h of 1 is equal to f of 5 is equal to 5 squared minus 5 is equal to 20. Given f of t and h of x, evaluate h of f of 2. You can pause the video and try to solve these problems. So first, f of 2. f of 2 is 2 squared for 4 minus 2, 2. So h of 2 is 3 times 2 plus 2, 8. So the answer of this one is 8. And the answer of this one, f of negative 2. Negative 2 squared for minus 2, 6. Then h of 6 is equal to 3 times 6, 18 plus 2, 20. Find the domain of f composed with g of x, where f of x and g of x are given. So we want to find the domain of f composed with g of x, which is equal to f of g of x. So we know f of x is 5 over x minus 1. If we want to find f of g of x, we just need to substitute g of x with x. So this is equal to 5 over g of x minus 1. So we want to find the domain of this fraction. What is the domain of this fraction? So it's a fraction. The denominator cannot be equal to 0 because it will be undefined. So we need to solve this, find the roots. That will be domain. And g of x also is a fraction. So its denominator again cannot be equal to 0. So another equation, 3x minus 2, we need to solve these two equations. So you can write it right here. 5 over g of x is 4 over 3x minus 2 minus 1. So we need to find the denominator right here without going any further, any simplification. Right here we need to find the denominator. So here we have one fraction, one denominator. So 4 over 3x minus 2 minus 1 is equal to 0. 4 over 3x minus 2 is equal to 1. 3x minus 2 is equal to 4. X is equal to 2. So all numbers except 2. And for this fraction, this denominator, 3x minus 2 is equal to 0. So x is equal to 2 over 3. So all numbers except 2 and 2 over 3. So d f of g is all real numbers except 2 and 2 over 3. We can write it as interval negative infinity to 2 over 3 union with 2 over 3 to 2 union with 2 to infinity. Find the domain of f composed with g of x. F of x and g of x are given. So again, f composed with g of x is equal to f of g of x. So here is f of x. So f of g of x is 1 over g of x minus 2. So we want to find the domain of this fraction. g of x minus 2 is equal to 0. One equation we need to solve, and this one is g of x also is square root. So x plus 4 must be more than or equal to 0. So let's solve this one first. G of x square root x plus 4 minus 2 is equal to 0. Square root x plus 4 is equal to 2. So x plus 4 is equal to 4. So x is equal to 0. So the domain cannot be 0. And this one, x is more than or equal to negative 4. So the domain is all numbers greater than negative 4 except 0. We can write it as negative 4 to 0 union with 0 to infinity. So 0 is not included. Write f of x as the composition of two functions. So f of x, we want to write it as composition of two functions. For example, g of h of x. So we can say that h of x is g of x is square root x. H of x is 5 minus x squared. Then g of h of x will be square root of 5 minus x squared. Same with this one. F of x is equal to g of h of x. So you can say that g of x is equal to 4 over 3 minus square root x, and h of x is equal to 4 plus x squared. Then g of h of x is equal to 4 over 3 minus square root 4 plus x squared.